Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I'm Richard. Richard on the MakeCode forum.
I'm Joey at JWonder on the MakeCode forum.
Joey was just telling me that Chimchar is a good Pokemon, and I don't know if I agree.
He's cool. I mean, I know he's another firefighting. I know that, yeah. But he's my favorite. That's not true. Torchic, and Combuskin. Wait.
Cyndaquil?
Cyndaquil is also good, but wait, Cyndaquil is firefighting?
No, not firefighting. No, Blaziken is firefighting.
Blaziken. Okay, I always remember Combuskin, which is the middle.
Combuskin's the middle evolve. And then you have, what was the pro wrestling tiger?
Oh, that's Fire Dark, isn't it?
Oh, is he? But he's all pro wrestler and everything.
Yeah, but he's like the heel.
Oh. What I didn't like was that Litten was such a good Pokemon name and Pokemon, and then they kind of turned him into this luchador wrestling guy, which I'm not about.
It might be. It might be that it's everybody just wanted to be Fire Dark, because that's what I wanted. Let me see. Well, we can continue. Shannon, you can do your intro too.
I'm Shannon at Shakal on the MakeCode forum.
Yeah, and this is a Pokemon live stream where we just talk about Pokemon while a static code snippet sits on the screen.
Antenna says Richard sounds a bit more muffled.
And a bit more. Oh, let me fix my headphones. Do I sound less muffled now?
Sure.
Maybe. Hopefully this comes out okay. I don't really have that much control over my sound setup, so.
Okay, it is Fire Dark, and and it is the heal Pokemon.
Oh, that's nice. I do like that. But I hate his design and him in Smash Bros. And everything about him. All right, so we're making a curling game. For those of you who are not familiar with curling, it's a game that looks very strange to begin with, where you have a stone that you throw, and you're trying to get it onto a target, which is on the other side of the arena. And you see this is actually showing my distance to it. So as this goes lower, the closer I am. And no, yeah, went right past it. And you're trying to land on the target. Closer to the target you are, the better you get for points. And the idea is you have two teams going. They take turns, and as you're doing that, they have a chance to knock each other off of the targets. And that's what we're going to be doing today, the knocking each other off bit. That's right, we're doing elastic collisions. This time, I've got some formulas up in front of me on a computer screen you can't see. And I think I'm going to be able to do it. I think. We'll see.
Yeah.
Okay, so let's start out by giving us something we can test at. All right, so I'm going to take this curling stone that I have. This is going to be my test stone. I'm going to put another curling stone right here. And this is how we're going to test our collisions. So let's go ahead and make our test curling stone. I'm going to just copy my code that does the curling stone. So like this one right here, get the Z depth. And that's, and let's go ahead and get the friction also. Oh, and also we were going to give some FX friction. So let's do that right now. Yeah, sure, 7.5, why not? Okay, so I'm going to make another stone right here at the beginning, and I'm going to put the start activity afterwards. And we're going to give it a Y that puts it in front of us. So we're going to set this to be a Y of just like 120 is probably fine, actually. There you go. Okay, so we got a stone right there. And right now, nothing happens when we hit it. All right, so we're doing an elastic collision, which means we're not going to worry about like momentum being lost and all of that stuff. But what we do worry about is what the velocity of these two things is going to be after they make contact with each other. And so to do contact in the beginning, we are going to use overlaps. I'm guessing that's not going to work super well, so we might have to change that later. But for now, we're just going to do overlaps. And in the future, we might have to detect a collision a different way by just doing points and distance, which will be fine. but overlaps is going to be easier to reason about for now.
We do have the distance formula as a block. So
yeah, let's just do distance. I think distance is going to work better. So
fortunate they're all circles.
Yeah, they're circles, which is very fortunate. So these guys have a radius. Let's see what it is. So this is it's 15 by 15 circle. You see we have this 1 pixel of transparency on the left and right. So the radius is about 7.5 pixels. So what we're going to do is inside of an ongoing update, we're going to make a for loop, a for of loop, and we're going to do another for of loop inside of it. And we're going to make 2 variables now, which is going to be collider, collide. Now let's just do stone 1, stone 2. Because I think I'm actually going to make a function to do the colliding stuff, So let's not use those variable names here. Okay, where was that variable I just made? Collider. I'm going to go ahead and rename this to be stone 1. Okay, so let's go ahead and put stone 1 here. Let's go ahead and put stone 2 here. And the first thing we want to do is, because we were, first thing we want to do is actually put in our array. The first thing we want to do is we do not care if a stone is colliding with itself, because of course it is. So we're just going to do an if, and we're going to say if these 2 stones equal each other, so if stone 1 equals stone 2, then we're going to do a continue. Joey, what's continue do?
It skips this iteration of the loop.
Yes.
The closest bound loop, so not the outer one.
Yep. So it'll skip the iteration on this loop, which is what we want because it's the innermost one, and then it'll keep going. The other thing is we're going to get every collision twice right now. That's going to be okay, though, because as part of our collision, we're going to move them slightly farther apart so that they don't collide anymore. And we're just going to do that in a stupid way, not the best way, probably. Okay, so let's make a function, which is going to be called collide. This is going to take in like stone. Let's do collider and collide. And what we're going to do is we're going to make collider be the faster of the 2. So we're going to make another function real quick before we even do anything with this. And it's going to be called speed. And taking a sprite. And this is just going to return the speed. And so fun fact about speed, you know the Pythagorean theorem? That's what we're going to be using.
Magic.
Yeah. So we're going to do return. We're going to do the square root of the Vx. You can imagine a triangle where Vx is one side and Vy is another side. And that's what we want. We want the square root of the Vx squared plus Vy squared. It's good that I looked these equations up and realized that they don't involve as many matrices as I remember. We're not going to be doing any matrix stuff.
That's good. That would be really sad.
Yeah, that would be painful. All right, so the 2 sides of our triangle are our Vx and our Vy. And now we're just going to put this inside of our square root. And we've got a speed function. So this takes our velocity, which is 2 speeds, an x speed and a y speed, tells us what the total speed is. So that is the speed without an angle.
Oh, we're on live today. Is that not? We didn't use any scaling stuff in this, did we? No.
Nope. Oh, right. Oh, right. I should go to beta. Whoops. Let's go to beta.
Beta.
Yep, I forgot to. Our usual disclaimer, don't use beta unless except for like just testing stuff out, you don't want to make a project in beta. And if you're working on a project, you don't even want to open it in beta because there's a chance that it will break. So always treat beta as like a little experimental section where you can try out the new features, but you should never work on stuff that you want to keep in beta because there is always a chance we will make some changes. Like we already made some changes to scaling that will break projects that were using scaling from earlier this week.
Plus, we just don't test beta unless we're going for a release, so it's always possible that everything's broken.
Yes, it's always possible that everything is broken. All right. So first, let's detect if we are colliding. We're going to go ahead and do a distance check. So let's go ahead and get our distance between stone 1 and stone 2.
If we need any more variables, can we do redstone and bluestone?
Why?
I don't know. It feels like Dr. Seuss.
Okay.
I was going to say, is this a Pokemon reference? But Dr. Seuss also makes sense.
All right, so if the distance between them is less than or equal to, we'll do less than or equal to 7.5, then we're going to collide. But like I said, we're going to make it so collider is the one that's going faster and collide is the one that's going slower. So we're going to do another comparison real quick, which is going to be comparing the two speeds. So we're going to say if speed of collider, what am I doing? If speed of stone 1 is less than speed of stone 2, and by the way, because we are calculating the speed, it's always positive. So we don't need to worry about one of them being negative. Then we're going to call collide. And stone 2 is going to be our collider. And stone 1 will be our collidee. Else, we do the opposite. So this one will be stone 1. And this one will be stone 2. All right. And so the reason it's important that we have a collider and a collidee is that I want to know which one I should be nudging out of the way. Okay, so basically one is going to nudge one out of the way because they are too close together right now. So first thing we need to do is we need to nudge them out of the way so that they're no longer overlapping. And then next thing we want to do is we want to calculate their velocities should be now. Okay, so we're going to nudge the collidee, I think. And the way we're going to do this is I'm going to make another function right now, which is going to be heading, and it's going to take in a sprite. And this is just going to give us our angle. By the way, I'm going to be using radians today. I know we normally do stuff in degrees, but there's no real reason for us to use degrees right now because we're not actually going to be putting degrees. We're not going to be typing any degree amounts in. So we're just going to keep everything in radians.
There is a block for this one, right?
Oh,
angle.
This is the one that does not have one. Yeah.
This should be a block.
Okay, so we're going to return atan2 of the sprites vy over the sprites vx. If you are wondering what the atan2 is, don't ask me, I can't remember. Trig was a while ago. It's the arctan squared, but that's all I can say.
Yeah, it's a weird. Is it arctan squared?
Isn't it?
I thought it was like some weird formula of like dividing. Yeah.
I thought it was.
It's the arctangent of x1 divided by x2, choosing the quadrant. Just whatever. Don't think about it.
It's not important. All you need to know is that if you have something with an x and a y, and you want to get the angle, all you have to do is put the y on top, the x on bottom, and there you go. You now have the angle from one to the other. If there are two things and you want to find the angle between them, you subtract them, and then you do it. Easy. Okay, so what we need to do is we need to figure out how far we need to move this thing. So we're going to use our distance block again. Let's go ahead and grab this out here. And we're going to find out the distance between the collider and the collidee. Then we are going to take this and we are going to subtract it. Subtract 7.5 from it. Oh, forgot about that bug. So the distance by minus 7.5 is going to be the, oh, sorry, it should be the other way around, huh? It should be 7.5 minus this distance. So because we know distance is less than 7.5, subtracting this is going to tell us how far we need to move to no longer be overlapping. So now that we have this, we're going to go ahead and make a variable which is going to be called temp number, or no, we'll do nice variable names.
Do we have the angle?
What?
Oh, I was thinking we could just do place at angle. It might be, I guess it's going to be the same. This is pretty much the same anyway. Never mind.
No, you're right. We can use the place at angle. I think that's a good idea. So we're going to do place collide. And then for the angle, we're going to do the angle between them. So there is a block in this for sprite utils. So we're going to do the angle from the collider to collide. Is that right? Well, it's either right or wrong, and it'll be very obvious if it is or not. And set this to be 7.5. And we're going to make this collider. All right, we should now see something if we run this code. Right, this needs to be 15. Because we're doing the distance between the two centers. We're not doing the radius. Yeah. Okay, let's try that again. There we go, all right. Yeah, so we're colliding and we've stuck together. Yeah, and this is not what we're gonna be doing. We're gonna be doing the nicer collision stuff.
This is how it works though, when the one that's being hit has 0 mass, right?
Yes, true. No, I'm pretty sure
and
you're
it's
correct.
made of glue.
Yes. And this could be an inelastic collision. So if you have an inelastic collision, they might stick together. Mm-hmm. But elastic collisions are just so much easier, guys. Trust me, we're going to do elastic collisions today.
Plus, I mean, elastic's just more fun than inelastic for most stuff.
Yeah, it's true. But anyway, we know we have the angle right because this seems to be working just fine. Okay, so we've got that. We've moved ourselves out. So now we just need to set the Vx and Vy of each of our sprites. So we're going to need a few things to do this equation. The first one is going to be angle of, let's see, what's this called?
Angle of incidence? Is that what you're going for?
Yes, that is what I'm going for. But this is just going to be the angle between our two things. So it's actually just going to be this thing we've already calculated. So we're going to just put this out here, grab this, put that right there. Okay, so this is our angle of incidence. We're going to need two other things, which is going to be collider angle, and we're going to do collide angle. And this is just going to be that function that we made. So the heading function, we're going to be using that to get both of these. So let's make this collider angle, and we're going to get the angle of our two things. By the way, I should have said up front that this is going to be a trig stream. This is going to be a trig stream.
It's a good thing it's Friday. Friday is the weird stream.
That's true. All right.
This one where we can just do pi minus to get the other one, I guess. Oh wait, no, because we were getting the heading of the velocity.
Yeah.
Are we over-engineering? Are we over-engineering a little bit because only one's going to be moving at a time?
Not necessarily, because if we have a field with a bunch of them.
Oh, you could like hit each other. I guess so, yeah.
Yeah. So.
Plus, we could always add ones that you have to dodge.
Plus, the equations I have, the equations I have, Joey, are for both of them moving, and I'm not going to figure out how to simplify them live. All right.
Okay, that makes sense.
Okay. So the first thing we're going to do is we're going to calculate the Vx of our like collider. And to do that, we are going to use an equation that I have in front of me. So let's do this. we're going to go to sprites and do the VX. I really hope this works. I do not want to debug this. This is going to be a giant block, by the way, by the time we're done with this. Okay, so we're going to get the cosine of the angle of incidence. And this is going to be multiplied by let's see. I need another two variables, which is going to be speed of collider and speed of collidee. And this is going to be just like we did before. This is going to be a just value that is their total speed. And we're just going to be using that function we made. Aren't we glad I made functions for these things? By the way you know that we are not a physics stream is we are not going to derive all of these things for you. We leave this as an exercise for the viewer. We're just going to be looking at an equation off screen.
More like a textbook than a physics stream.
True. All right, now we're going to do a division. So let's go ahead and do a division right here. The denominator of this division is going to be the mass of the two things together. And we don't care about mass. So we are just going to set this to be 2. Everything has the same mass because we don't care. Okay, now the top part of this is going to be the speed of the collider times cosine of the angle of collider minus the angle of incidence.
For the denominator, you said, just to make sure, you said it was the sum of like the sum mass involved in the equation?
Yes.
Okay, that makes sense to me.
Yeah. And we're just going to set both of them to be 1 because that simplifies the math.
Yeah.
Okay, so we've got that. And then we are going to take this cosine that we have and, well, this whole times and cosine that we have, we're going to put this inside of a plus. And we're going to be adding to it 2 times the mass, which is 1. Times the speed of the collidee. Times, where's my cosine? Cosine of the collidee angle minus the angle of incidence. There we go. All right, let's go ahead and put this big thing back into here. And now we are going to do, almost done. This huge thing, pull this out. Oh, sorry, the entire thing I need. So I'm going to pull this out. We're going to do plus, and let's just do the plus part, and then we'll drag both of these into the plus. Isn't math in blocks fun?
This is really making me wish we had like a right-click inline or external.
Yeah. For real. Can we just do that? Can we just do that?
I mean, it's just an we don't care about. Can you right-click on the block? Wait, is that just there? External inputs?
Yeah. Oh, sorry. Do you want me to do that? That's not.
No, that's a bug. We
well, that's what I was talking about, but that's just a bug that slipped through that exists.
Yeah, it's always
Yeah,
been there. It's in Blockly, but we usually strip it out. So if you
Yeah.
want to file that on GitHub, Joey.
our rendering does not really have inline or external inputs. So
Fair
really
enough.
what I want is the ability to have a text field where I can just type some JavaScript.
That's true. For this, I think external should work for whatever. But I will file that.
Yeah, we do
All right.
handle external inputs now because of the updated Blockly render. It doesn't look like great, but
Okay. Okay, so for this next one, we want the speed of the collider times the sine of, and then we want that angle of, we want angle of incidence. No, sorry, we want collider angle minus the angle of incidence. And then we want to multiply this times the cosine of the angle of incidence plus pi divided by 2, which Joey is.
It's pi divided by 2. Just send an arcade sprite util.
Is it really?
Let's go down. Well, pi is.
No, I want pi divided by 2.
Well, wait. Look under nan. Look under nan.
Okay, I'll drag out more blocks. I was just going to type in, 1.57, whatever it is. All right, anyway. We did it! Okay.
Divided by 0. Yeah.
Thank you, Joey. Okay. Now we just need to put both of these inside of the plus. So this one goes in this side of the plus. This one goes in this side of the plus. And that's not the longest block I've ever seen. It's close, but it's not. Okay, we're now going to duplicate this because the y part is going to look very similar. It's just going to be swapping some things around. So, okay, the v1y, this first part is, let's see, I believe the same. Yep, this first part is the same, except we want to do the sine of the angle of incidence. Go to the other part of our plus. And now this one is the same, except this is going to be the sine. Okay, that was easier than I thought it was going to be. That actually wasn't bad at all, was it? All right, so we're just going to take this thing and we're going to put it into our set VX block like that. Now we're going to do the same thing for the VY. Beautiful. And we are now going to do the collide velocity. So first, let's see what happens when we run this. Okay, wait, this is exactly what's supposed to happen. Because when two things have the same mass and they collide head on like this, what's going to happen is 100% of the velocity is going to be put into the second one.
Mm-hmm.
So let's move over to the side a bit and then do this. And nice. Wikipedia didn't lie to me, guys.
This is pretty fun.
Yeah.
Who would have thought that our best math stream would be shuffle, or it would be curling?
Yeah, who would have thought? We're gonna I'm gonna take this at the end and I'm just gonna put this somewhere. And whenever we do another elastic collision stream, we're just gonna reuse this. So we never have to do it again.
Just gonna put it in a nice box right next to the refrigerator.
I mean, we could make an elastic collision block.
Extension, yeah.
Yeah, we could just do that.
Just in an on-game update implementation, or in the interjected?
No, we could just make a function that is do elastic collision between
do elastic collision AB. Sure, yeah. That'd be easy.
And we assume that they have collided. It's up to you to figure that out.
Yeah, that makes sense.
Yeah, we should do that.
Do we want to assume? Well, do we want the nudging as part of it? Because then we would not want to assume. It doesn't matter. It's all figure outable.
Yeah, I mean, we could do the nudging, I think. Anyway, all right, so this is going to look very similar for the collide. So let's just duplicate this. All we're going to do is everywhere we have collider, that's going to become collide. So we got speed of collider. Let's go ahead and make this speed of collide. Moving over, we have collider angle. This is going to be collide angle. All right, we have speed of collide. So this is going to be speed of collider. Collide angle, going to make this collider angle. Speed of collider, change this to be speed of collide. Collider angle, make this collide angle. And there we go. All right. At least I think that's all we have to do. Makes sense to me. That's all we have to do. Whoa! Okay. Great. Closer. What is this?
The sign on the velocity of the incident one is flipped.
Oh, should it be? It should be, shouldn't it? So it's not the sign. We need to add pi to it.
Yeah.
I meant like the direction.
Yeah, so we need to add pi to it. So we can just do change angle of incidence by pi.
I think you just want negative of whatever your VXPY is.
What, really?
Shouldn't it just bounce in the other direction? Or it stops moving entirely?
Well, I mean, so what is the velocity of the second object going to be? It's not going to be exactly the same in the opposite, is it? Is it?
Yeah.
Wait, is it? Because they have the same mass?
For the same mass in an elastic collision, I think it's
Well,
No,
no.
it should stop
It's
completely.
if they're hitting straight on, but what if they're not hitting straight on? If it's hitting straight on, like if it's hitting like this, then it should be like.
Yeah, but it's moving in the same direction right now. So the direction is wrong.
That's true. So
right now it's like a Team Rocket blast off sort of thing.
So your hypothesis is 1, 2. We just put this inside of a 0 minus.
I think it'll work.
I'm incredulous, but Shannon is the math wizard.
Oh, not with this.
Well, that's a different result.
No.
How can it not be moving at all? You didn't change the...
It is odd, isn't it?
Yeah.
get rid of this pi business. Oh, simulator's getting slow. I refresh.
That was a very quick slowdown there.
I mean, it depends on how many times you refresh the simulator, and if you're debugging stuff, it tends to be.
Why is this one? Oh.
Okay, so I think what's happening is they're like colliding and then immediately colliding again because they're going in the wrong direction.
Yeah.
So I'm going to, oh, I refreshed. Damn.
We could at the
Darn.
very top put a if like speed of this is faster than speed of that or something.
I don't know if that's what we need to be doing though.
Yeah, you're right. We should probably actually figure it out.
Yeah. All right. You guys vamp for a little bit. Choose a discussion topic while I read this.
Pros and cons of inline inputs.
They look nicer, but they get
Oh,
very
wait.
long. Wait, no,
Inline is lengthy. External is down. Is that true?
Yeah. This is true. I have an actual question for you, Joey, extension expert, which is when you're coming up with an extension, how do you think about what blocks should be in it?
I just think about what blocks are in. I don't know. I just put them up there. If you want to put a bunch of blocks, you can always cull them later. Just throw them out there, and then we'll cut them down.
Do you like write like a sample program in your head with like the blocks, or like?
I just think about what I've made a lot of blocks in my time. I've been around the block a few times, and so I mean, usually just get the ones that feel like they're obvious out, and then play around with it until like add whatever you're going to use it for, because presumably you're making an extension for a reason, and then add more when anybody yells at you.
So if someone was a beginning extension writer and they were trying to get started, what advice would you have in designing blocks?
I mean, I think that one is the main one. It's that if you like have a thing that you're making them for, if you have a game, make sure you can make that game with the blocks, right? Like make sure that you can, if you have it, the blocks existing in the code, just try and extract them into a function first, maybe. Right? Like if you can put them into a function in the workspace in a block, then you just have to copy and paste it out, and then you can just make that a block.
Nice. And then question from chat, which is, why does the simulator glitch out and then you have to click the close arrow and the open arrow and the close arrow and the open arrow again?
We're bad at writing code. Sometimes things just sneak through, and like 4 people on the team have looked at this for like a day and then realized they have other work to do and then come back and not fixed it yet. So we have to just bite the bullet and fix it sometime. But everybody's bad at writing code, so it's okay.
We're a small team. We do the best we can, and we try to fix bugs. There is a specific thing that's been happening recently where the simulator gets very slow. I think that's probably what you're referring to.
Yeah.
But we need to fix that. It's kind of complicated, and a few people have taken a look at it, myself included, and we haven't figured out the best way to do it just yet. Oh man, why does Wikipedia only give the V1 velocity, and then it says like this is the velocity for the first ball, and then it doesn't say anything about the second ball?
It's left as an exercise to the viewer. I mean, it should just be the exact opposite, right? Like if you just were to take the equation for the first one and just swap any parameter, like swap any a, b.
I did that though.
You're right. That is what we did.
Right? I mean, let's look at this real quick, okay? So we're setting the Vx and Vy of our collide. And so here, collider, collide, collider, collide, collide, collider, collide, collider, collider, collide, collider, collide, and that's it, yeah.
Is the angle events? Oh, this is what you had before with the pi with add pi to angle of
Yeah.
incidence.
Mm-hmm.
Wait, was that one changed by pi or was it set it to pi? We did it.
I did change by pi.
That feels like it's necessary, but if it didn't work before, then I'm not sure.
I mean, they do have to be the same, right? Because
Well, the angle of incidence is the angle
that's
between
true.
like A and B. So it would be the exact opposite for the angle of incidence if we're calculating it from the perspective of B to A.
Right. Okay. So let's do that again. We'll change our angle of incidence by pi, which is the same as making it 180 degrees different. Do we also need to reverse the other angles? No. Right?
Do you need to reverse the other angles? The other angles are calculated independent, like they're calculated from the things and not between them, right?
Yeah.
Because it's all like the speed is self like independent in the so is the collision.
Mm-hmm. Okay. What if we do 15.1?
Yeah, I was thinking that one too. So it was just calculating it twice. That feels right.
All right. Yep. All right. Okay. So all we were doing was we were not putting them far enough apart. So they were just constantly colliding with each other. And I'm guessing that rounding errors were causing them to accelerate. All right. Cool. This is pretty cool, I think.
Yeah.
Right?
Plus,
The first time
we can make any number of games off of this. We could even make shuffleboard.
Oh, the lesser curling. The thing is, we can tell our thing is a little bit off because it should be stopping when this collision happens, I think. But whatever, this is fine.
Why isn't it stopping, Justin?
This is more realistic to what would actually happen, but yeah. Yeah, I don't know why it's not stopping. Don't think about it too much. Your brain will break. All right. We've got basic collisions now. Perfect. Let's go ahead and collapse this and tuck it away. Forget about it.
Got another question in chat, which is, do you guys have any sort of general tips for someone who's new to the coder community? They code 3DS styled games, like the.
General tips.
Yeah.
If you're writing open, wait, what?
I've never owned a 3DS, so I don't actually know what that means.
All sorts of games on there, yeah.
Yeah, there's all sorts of things. It's basically just like, you know, a Switch with worse graphics. So it has all of the capabilities to do 3D stuff, is what I'm saying.
Mm-hmm.
I love the 3DS. It's my favorite portable game console, Switch included.
If we're talking about just like new to arcade in general, skill maps, the beginner skill map, and the many other ones that exist now. I don't remember all of them off the top of my head, but there's a ton of them, especially the Zookeeper one, because if you do that one, you can get the best badge, just so you know. And if you sign in, you can get badges. So do Zookeeper and get the best badge.
So I think one important thing is when you're making a game, get feedback early, and also, you know, don't get too caught up in what you're doing. Feel free to get, you know, let somebody tell you that it's terrible and then make changes.
Yeah.
Also,
if you like get stuck while you're making a game and you just don't feel like continuing, you can always just set it aside and come back to it later or make something else, right? I have tons of games I've just completely thrown away while I was writing them, but you still learn some stuff while you're doing them.
Shannon,
we also have them as a stream entirely, right? We have a big graveyard of games that we're definitely coming back to someday.
Maybe like look at other people's code. So if you see someone doing a kind of game that you think is cool or you're interested in, you can look at the code and see if there's anything you can borrow or mod from theirs.
Yeah, that's a good one. Okay. So let's get back to our sweeping code. We're going to go ahead and get rid of our little test stone. So get out of here, you. And let's check out our sweeping. So when we sweep, we create a thing, like a little sprite that we use to make changes to the friction of our stone. So we're actually decreasing the Y friction every single time. And we are also adding some VX to make it go left and right. We're going to also, we already made it so that we now have some FX friction, but let's go ahead and make it so that our FY friction creeps back up. So we're going to do game update, on game update. Let's do an interval. I think what we're going to do for this is every 100 milliseconds, we're going to loop over all of our sprites of kind stone. And if the FY of our stone is less than our magic number, 7.5, then we're going to change the FY by 0.1, and we're going to cap it. So value. We're going to make it so that if the thing is greater than 7.5, we just set it to be 7.5. So the idea is it'll go down while you're sweeping, but when you stop sweeping, it'll go back up. And we should also set a minimum because there will always be some friction. So we're going to do, we're going to put this inside of an else if. Or no. We're just going to leave this as is. And we're going to go to our thing over here, and we're going to say if the FY is greater than whatever our minimum is. And I have no idea what this should be. 5, I don't know.
Yeah. So wait, you'd have to hit it, what, 250 times to get down there? Within...
Well, it's happening every frame.
Oh, it's happening every frame. So it's going to be hitting like 5 times per, at least. Okay.
Yeah. Okay. The VX is changing way too much. I'm going to change this to be 0.01, and hopefully we'll still see something happening. Cool. Okay, I can still curl it like this.
Nice.
Still changing by too much, I think, actually. I want to make it so that you can curl it, but it's much more gradual, you know? So, yeah, let's make this like 0.05. All right, that's a problem. We need to make it so that the thing we create when we are sweeping is closer to the stone, because right now, if you're going at a harsh angle, you can't actually get to it anymore. So we're going to make it so that we have an on-game update around here that controls where our broom is. Oh, is it this one? Yeah, it's this one actually. And we're doing the top 2 plus the bottom. We're just going to set it to be the bottom and see what that does. Okay, all right. So let's see where this one lands. Oh wait, I haven't written the code to do more than one yet. Okay, so we're just going to cut you off at a certain point for the sweeping. So I think we will make it so that you have to stop sweeping like when you are close to the house. I was trying to remember what the name was.
They call it the house?
Yeah. So we're going to say if, undo, there we go. If the distance between the house and the current stone is less than, and let's see, we want to do it like when you're basically on it. So like less than, we'll do it like 80. Then we are going to destroy the broom. Oh, I remember, I figured out, Shannon, there's another block that we added that we didn't go over in our preview of all the new stuff.
Did you add destroy all block at all?
I did, yeah, we finally have it. Inside of sprites, there is now a destroy all sprites of kind. So destroy all sprites of kind player. It's great. Okay, so we are going to do that, and we're going to set our current activity to be scoring, I believe is what I called it. And then finally, if the speed of the current stone, where are you, current stone? Yeah, you right here. Sorry, I need to put this inside of a current activity equals scoring. If the speed of the current stone is 0, then we set our current activity to be, make sure we also call start activity for this. We're going to set our current activity to be, I don't remember what I called this, aiming probably, aiming. And this should put us back to the start. Let's see. Flapjacks. This stream is, of course, brought to you by our sponsors, Flapjacks. Remember, they put the X. They put their X in Flapjacks. What, Joey?
Why'd the camera stop following?
Because the camera follow code is actually in the code for the sweeping.
Okay, that's what I was. Okay. You'll never know how you did.
Yeah. Okay, let's go ahead and fix that. So we're going to go to our camera follow code, which is right here, and we're going to put it in here also. All right, let's try this again. And how does that jingle for Flapjacks go?
Flappity flap, Jacks in the box.
That's it. Flappity Flapjacks in the box. Please give us our money, Flapjacks. Yes!
Nice.
Let me see if I can hit it out. For some reason, I think sweeping is slowing it down, which is working for me. But here, no, I'm not going to sweep it all this time.
And Senator Adreno says, the stream is sponsored? Question mark, question mark.
No, it's not. In a way,
mean,
it's sponsored by MakeCode.
It is, right? Like, technically, we're being paid.
Guess that's true.
Like, we have a salary.
In that sense, we are sponsored. But in the sense where an external company is paying us money to talk about their product, it's not. And flapjacks is a thing that Shannon made up last stream. So, as it bears no relation to anything that is actually called flapjacks with an X, which probably exists.
Yeah.
Yeah, I think there's just like a lot of variability between how fast it ends up going. Like, I feel like the friction is just very imprecise.
Yeah, that's possible. You should put a bunch of gauges on there so you can like detect everything, like a wind meter and like a velocity with an angle, like a compass and all that.
Yeah, we should do that. Okay, well, we're at 2 o'clock, so I think that's going to be it for us today. Maybe we'll come back to this game. Maybe we'll do something else with the collision. I think we kind of actually finished this game for the most part. The only thing we didn't do was scoring, and I don't know if we want to do a full stream for that. Right? But you know what? I'm going to take this collision stuff and I'm going to put it into an extension, and we might make some fun games with it. We wanted to do billiards before, so maybe we'll do that. That'll be fun and easy, right?
It'd be really fun, satisfying to do a good break.
True. All right. Well, anyway, for MakeCode and flapjacks, we put the X in flapjacks. I am Richard. Richard on the MakeCode forum.
I'm Joe at JWonderl on the MakeCode forum.
I'm Shannon, extra cow on the MakeCode forum.
And all together, guys, flippity flap, Jacks in the box.